Welcome, everyone, and happy to have you here today at MATHurdays. Um, Excited to hear where you all are coming from in the chat box, and excited to follow some new folks as well. All right, folks, we have a wonderful session for you today, and we have a special guest today. And just to give you an update, we are going to be looking at a math routine called Mysteries and a rich task from illustrative math called Three Hidden Rectangles. I've got a special guest, Christina, with us today, and Christina is a graduate of the George Mason Math Education Leadership Program and does some pretty amazing work. I'm going to let you go ahead and take it away and introduce yourself and tell us a little bit about your experience with both of these in your classroom, Christina.
Sure. Hi, everybody. I'm super excited to be here. I have been doing Mysteries. I teach fifth grade, advanced fifth grade math. So we teach sixth grade math in fifth grade. And I found that the conversations that we have around how they change their estimates as they get new clues has been really, really powerful in building their number sense and also their estimation skills. So I just think it's a really great task to routine to use in classrooms, and I use illustrative mathematics quite often for different activities because it really helps to build their critical thinking and them being able to talk through math problems, and really builds that discourse. So I'm excited to do this with you guys today.
I'm super excited to have you. All right, so we'll start off just kind of looking through the first couple slides. Slide 2 is a bank of templates. I've got a lot of things on my website that should hopefully make your lives easier so you don't have to start from scratch. So please check out the templates. And if you'd like to if you would like to see a recording of this Mather Day, along with many others, I have about 25 up here now. They all include some sort of a routine and some sort of task that can be applied to multiple grade levels. Today, we're going to talk about taking this task from third grade all the way up to pre-algebra. So hope you enjoy that. Before we jump in, I want to take a moment to see what successes and celebrations are happening out there in the math ed community. So feel free to add to slide 3, 4, or 5. Insert images, GIFs, Bitmojis, text boxes, and tell us what's going on. What are you celebrating today? I hope I'm gonna get to see some Halloween costumes also. I've got one down of Hermione Granger, that's my daughter. And I got some pumpkin carvings. And Laura, love your costume. How's it going?
Good morning, Teresa. I was so worried I was going to be late because I just walked in from my flu shot. But my kids and we did a virtual Halloween end of first quarter celebration. So my kids took selfies of themselves because I taught them how to upload from the camera onto Google Slides. We just had a lot of fun, and we got to end the first quarter on a happy note.
Oh, so lovely. Sally, tell us a little bit about this activity you have posted on slide 4. This looks so engaging.
Sure, Teresa. So our sixth graders have learned about fractions, decimals, and percents. And to kind of tie it all together, they had a real-world task of a city where there were certain constraints. That's all the constraints are over there in that green box in the top right corner. And then they had a grid and different tools they could use to paint. And so we ended up with all these different solutions, and they had a certain percentage of the city that had to be schools. It's a city called Lakeview, so there's a certain fraction that were lakes, and they followed all the constraints and had a really good time.
How fun. Oh, I'm excited to do that. Wonderful. And Sally, if you do have a link to Google Slides and you're willing to share it with other people, feel free to pop it in here. That's how we kind of share out and get other people using some things too. Gail, tell us about slope and not just a formula.
I had my students looking at wheelchair ramps and ADA compliance and a ratio of 1 to 12 versus 1 to 20, and which would be inside and which would be outside, because which is steeper and which is less steep.
That is really interesting. And you know, Gail, that goes back to when I was teaching algebra several years ago. I had them do a project where they were going to design ramps for different heights, you know, thinking about wheelchair ramps. And one thing I didn't take into consideration was that slope, that grade. There are, you know, certain rules and regulations that it can't be too steep. And so here I thought I was just doing a math problem, and then my students, you know, investigated that and found out like this would not pass. And it was really neat to relate that to real world.
Yeah.
Wonderful. Thanks so much for sharing. Chelsea, welcome back. How is Padlet, and how are you getting student voice? Oh, I think maybe. Oh, just joining again. Very cool. You're getting also a sneak peek of what we're going to be doing next week. I am assuming that one is Andrew's up on slide 3. Hi, Andrew. How's it going? We're going to use this one next week, but how is this?
Can you hear me?
Sure can.
Yeah, it's funny. I actually did this activity with my colleagues, actually. One of our product managers and the CEO sort of let me play teacher and do this little activity that I know you and I kind of did the other week. And it was sort of really funny to see all the things that they started noticing and wondering about their own understanding of multiplying decimals and whatnot. So I definitely have some work to do on this activity after seeing how even adults struggled, but I think there's still a lot there.
Very exciting. I can't wait to dig in. Hi, Chelsea. Welcome back. How was Padlet, and how are you getting student voice?
One of my teammates uses Padlet a lot in her class, so I tried it with mine. We have a big ESOL population at our school, so it was nice seeing them have the opportunity to speak, even pictures and GIFs, so it's pretty cool.
How cool. Well, welcome everybody. So glad you are all here and sharing your successes here, loving all the reasoning and problem solving that's happening. Let's jump right into our task and our routine today. As mentioned before, I'm going to have Christina take it away and do these implementations. But if we start off on slide 6, I just want to mention that Mysteries is a fabulous routine created by Steve Wyborny. There is the link to Steve's website as well as his Twitter handle if you want to follow. And we have done some very minor modifications to really enhance the online features while still keeping the routine as exactly the same as we can. So Christina, so excited to have you here today. Go ahead and take it away.
Great, thanks so much. And also just as a follow-up to what Teresa just said, if you even just go to his website, most of these routines are already done in a PowerPoint, so you can always just project the PowerPoint and work on it with your kids for sure. I like to change them into Google Slides. It works better for my population and my students. So using Mysteries in the online classroom, we want to have kids estimate with basically no information, just a picture. And then as they reveal one clue at a time, they're going to revise their estimates, and you want to keep a log of what their revisions are as they change their estimates to sort of see if they're getting like closer and closer to what the real answer would be. And then also having them share over mic their thinking throughout the process is really, really important. So if everybody joins me on slide 8, we are going to try to figure out how many beads are on this string. Okay, so you're going to take a look at those two bowls, look at the beads that you see there, and then when you have an idea, you're going to go to slide 9, choose a box, and put your estimate in the box. When I do this with my kids are usually either assigned a number so that they know which box is always theirs. Last week I made them use the box that was the number of who they were in the participants list. And as people are putting their estimates in, you should notice a wide range of estimates that you might have at the beginning of this task. Would anybody like to turn their mic on and talk about their thinking about their initial estimate?
Hi, this is Laura. I thought there might be 63 beads. I looked at the first jar and like visually kind of thought, okay, maybe 30. And since there are two jars, 30 and 30 is 60 plus the 3 beads in the middle. I might be really off though.
Awesome. Thank you for sharing that. And when you're ready, everybody can join me on slide 10 and we will reveal our first clue. So is the total going to be odd or even number? The two bowls are holding the same number of beads. So based on that clue, you will move to slide 10, find your same box, and put your new estimate. When you put a new estimate, make sure you put a comma between your first estimate and your second. Or you can write it underneath it. Is there anybody who'd like to share if they now know that the estimate should be an odd number or an even number and how they know?
Now that I know it's going to be odd, I just added one to my previous.
How do you know that it's going to be odd?
If there's the same number in both bowls, so if there's 1 in both bowls, then the answer is going to be 2 total in the bowls. If there is 2 in each bowl, then there's going to be 4 total. 3 in each bowl, 6 total. So when you double it, your answer is always even. And then there's 3 on the string. So whatever your even number was, plus 3 more is going to be an odd number.
Hey, thanks so much for sharing that. When you're ready, you can join me on slide 11 for your next clue. So the answer is not a multiple of 5. And you can put your new estimate on slide 11. Go ahead, Raha.
Hi, Christina. I'm wondering if I wanted to keep my estimate, if it wasn't a multiple of 5, can I keep it?
Yeah, you can keep your estimate, but type it another time just so you know that you've made 3 estimates so far.
Awesome, thank you.
Welcome. So is there a digit that we know, besides we know they can't be an even digit in the ones place, is there another digit that we now know cannot be in the ones place? Yes, it has to be an odd number ending in 3, 7, 9, or 1, exactly.
5, we will not have 5.
Right, thank you. Okay, if you're ready, we're going to move to slide 12. And clue 3, your answer does not include the digit 3 or 7. You can put your new estimate on slide 12. So I see Teresa just put in the chat that it can't end in 0, 2, 3, 4, 5, 6, 7, or 8. So what can be in the ones digit at this point? 9, yeah. 1 or 9. Absolutely. All right, the next clue is on slide 13. The answer is 1 more than a multiple of 5. There's somebody who can turn on their mic and explain what that means.
Hi, it's Araha again. So if it can be if it's not 0, so another multiple of 0 is ends in 5, but it can't be a 6. So it has to be 1 in the ones place, because if I have 50, which is a multiple of 5, then plus 1 would be 51.
Great, thank you. And now we are going to see our final clue. So this clue will be the last clue you get before you make your final estimate and we reveal our answer. It is on slide 14. And it is that the answer is not a multiple of 3. But is 151 a reasonable estimate?
Hi, folks. That was mine. I try so hard with estimates. My spatial reasoning is never quite there, but um, yeah, it's probably a little high, but either I'm always way too high or way too low.
And that's a conversation I always have with my kids when we're doing this too, right? Is your estimate reasonable? So it's, yeah, you might be matching all of the clues, but is your estimate actually reasonable? So that's a really good conversation to have with the kids as you go through this. So if you are ready, we can reveal our answer. And then of course, this one has a bonus question after we reveal our answer. can you actually determine how many beads are in each bowl? And I saw a lot of people had 61 as their final estimate. So how many are in each bowl? Yeah. Awesome. Does anybody have any questions about how they would use this in their classroom with kids? Yeah, I've done this a couple different ways, and I have done it with my kids where I got a new board to put their estimate at any time, but having the log follow them where they can see their really just have their previous estimate right in front of them is really, really helpful. I've also done it where you can actually keep track on a hundreds chart. Exactly, I see some Sally putting that in the chat too. And then that way they can keep track of which numbers actually are not possible answers, but you just have to make sure that it's going to be one that the answer is actually going to be under 100, because otherwise they get a little confused. Yes. Awesome. So I hope that people can see how they can use this in their classroom with their students. And the website is great because there's so many that are already made for you, and they are broken down by in grade bands also, so ones that are more appropriate for K2 versus like 3 to 8. And they're actually not that hard to make on your own either if you are feeling creative and you have lots of extra time. So I think we're ready to move on to our task. Yeah, kids can make them too, for sure.
And Christine, I'll go ahead with the first couple slides here. So we're going to move into our rich task. I always like to ground why we do rich tasks in the research that NCTM has released in Principles to Action. These are the 8 math teaching practices, and rich tasks are not only engaging and fun, but they do help students understand the material because they are based in these 8 math teaching practices. And before we start, the problem solving oath is now up. As I read it aloud, read it to yourself. And if this is something you want to pledge today and hold yourself responsible for this, feel free to put your name in the chat box. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. And then I'm going to bring it on over to Christina now that we have all these wonderful problem solvers with us today.
Awesome. So if you join me on slide 20, this is our task for today. And as we mentioned earlier, it comes from illustrative mathematics, which we found out is the proper way to say it. Teresa and I both found out the other day that we were saying it improperly, but that's okay, I guess. So here's your task. You need to find out the area of this figure. But you need to find out the area by splitting it into exactly 3 rectangles. None of the rectangles can overlap, and it must cover the entire figure. You have to figure out how many different ways can you do that, and then what is the expression that matches each of the rectangles, the 3 rectangles you've created. And then also what is the actual total area. Use that information to actually find the total area. Any questions about this task? Okay, then I think Teresa's going to make breakout rooms for us.
All right, I'm going to go ahead and create them now. And the rooms are on the slides below, starting on slide 22. You'll just see your group number up there. If anyone needs support knowing what group they're in, I'll be popping in and out of the rooms. Hi, group 2. How's it going?
Oh, fine, and you.
Good morning.
Is apart.
So it looks like we're on slide 23. And we have to split this up into lots, or just 3 rectangles. Where's everyone coming from?
I am from
Hi, Lee from Florida. Welcome.
Karen from New Jersey.
Welcome, Karen.
Dion from Virginia.
Hi, Dion. Where in Virginia are you?
I live in Norfolk, but I'm a math specialist in Portsmouth.
Oh, right on. I lived down in Virginia Beach area. I grew up, my dad was in the Marine Corps and we lived down there.
I just moved from there probably about 4 years ago
Oh,
because
yeah?
I was living in Virginia Beach, driving to Petersburg every day. That was like 3 hours out my day. Oh, Taylor came. Good. Can put her in group 3. 2. Okay, so let's see.
Oh, someone's got a neat expression there with like the 3, I must see those as like 3 vertical pieces. The blue vertical, the
Okay,
yellow vertical, the green vertical.
I was. Oh,
So I noticed I have the same rectangle pattern. I'm the first one and someone else did the second one. When you teach rectangles, does it matter to you which number goes first when you're multiplying? And like what grade do you teach?
Well, I'm a math supervisor in Hamilton, and I started teaching in Hamilton in the high school. I've had experience from kindergarten through 8th grade as well. Of course, I would say order never matters. The more solutions, the better, and the more you can illustrate the properties, the more exciting it gets.
Yeah, I find that I don't really think about order too much, and part of that is a bit of a memory issue that I have, um, that I can't remember which one it is, but I feel very fluent in like the rationale why it might not matter. Um, but I also know at certain grades they talk about when a number comes first, what that means in terms of number of groups or number of items. So I'm always interested in who teaches this and what grade levels you teach.
I think that really leads to that whole conversation of how important it is to have good vocabulary in math from elementary all the way through.
Mm-hmm. It's interesting. I thought there would be many more different solutions here, but I'm kind of finding myself a little stuck in just finding a couple. Oh, I think that's another one.
Oh, let's see. I don't think I did that right. If you did, oh, you could do 2. If you did 2,
Like that middle block is kind of keeps getting in the way.
2. This
Oh, yeah, there you go.
is this one here. 2 here. This one 2. 2 times 6, 10, 12. 2 times and 2 times. Oh, they did that one. And if you did, oh, they did that one. If you did,
Okay, I've got one that is kind of, I think, breaking the rules a little bit, but I'm going to go with it. So I'm going to just kind of stick it off to the side because I don't know that it technically fits, but I'm always trying to break the rules. So um, I extended the rectangles and just said that I'm only taking 2/5 of this rectangle and 1/3 of the other one. Because technically they don't overlap. Ooh, and who did the one in the bottom right? Because your blue isn't covering it, but like it still maintains the same area. Lee, that one's pretty cool. I like the way that just kind of visualizing that one filling that section there, that I can now see this as just a single length times width and not like a staircase problem.
Um, 2 times, I want to do, this one, 2 times that. Let me do that. And then,
Lee, you wrote there that you weren't sure if you were allowed to rearrange the area. And that's kind of one of my favorite things about these tasks is like, yeah, the directions say to do it a certain way, but I think like as soon as we start to think outside the box and give us the like agency to be like, yeah, sure, why not? Let's try this out. It can really open up the way we see math. And I see this expression as 3 times 2 times 5. But there must be another way.
Hello.
Hi. Are you feeling good about this?
I am feeling good about it. So a couple of interesting things that came up as I was popping in and out of rooms is group one was really struggling with the idea of how do they know that they found them all?
Yep.
And so I basically told them, well, that's a really good question and something we're going to be talking about. So keep thinking about how you might know. But then group three was talking about the same thing. They're like, oh, we found them all. And I said, well, how do you know you found them all? And so then actually the people in group three actually had some good like reasoning behind it. So they might be able to share some of that. And then one of the groups started talking about how this can lead to distributive property stuff. So I thought that that was a pretty interesting thing too.
I love those because I think a lot of teachers can make the connections to the decomposing area as that elementary unit, but this idea of how do you know you found them all, organized lists, and also kind of relating to pre-algebra in terms of expressions can be equivalent in multiple ways, and distributive property. The group I was working in, I brought up another one that I found too. That's on slide 24 off to the side, where you're just taking like a fractional amount. So maybe we just bring that up briefly, but kind of leave it in the background. I don't know if kids would do this unless you were in the middle of a fraction unit or you said like the whole area was one. So I don't know that
Right.
that one's practical, but still neat idea to look at. Cool.
Oh, and just so you know, Andrew, I think his name is, felt that this would have been better served if we created this as an image so that this, like the background image, so that it couldn't move. I said, okay, well that's good to know. I was like, yeah, that I understand what you're saying.
Mm-hmm. Yep.
So
Alrighty. Should we pull them together then?
I think so. Can you start the conversation with everybody? Because I'm not sure where to start.
Yep, absolutely.
Okay, cool.
Hardest thing
Welcome
though is
back
like,
to the main room, everyone. I know those conversations were getting deep and awesome, but let's go ahead and share them out with the whole entire group. So welcome back. All right, so there were some really interesting things that came up in these conversations. And some of the ones that are presented in the unit were what are different ways you can decompose this shape to find the area. But as a bunch of math teachers who are in this PD together, we're going to dive deeper into this and start to think about this in terms of deductive reasoning and bring this up to a middle school level also. So without further ado, let's start off on slide 22. Slide 22 has 5 different versions on it, and there is another one that is blank. And group one, I believe you all were talking about wondering if you found them all. What was your thinking process on knowing if you found them all?
Okay, well, this is Chelsea. We were looking at the different ways to make 30. Um, we were stuck because we know that the factors would either be, well, in my mind, I was thinking the factors have to be either even or the one outlier is the 5, which is the odd, and it's a multiple of 30. So it's just difficult.
So you looked at multiples of, sorry, you said factors of 30 as your
Hmm.
strategy. And did we manage to get all of the factors here in the expressions? Let's think about that. If you're feeling up for it, feel free to fill in that box there. Factors of 30. Anyone can do this in our group. So if you don't want to use your microphone, but you want to participate, what are some of the factors of 30? And let's see if we have them all. So we didn't see a 2 and a 10, Gail says. And Lisa's, oh, Gail said 3. So Lisa, why can't we see a 1 or 15 if those are factors of 30?
We're limited by the drawing. We don't have any lengthwise 15s, and every rectangle. Andrew talked about in our group, that was the first thing he looked at was 1, and he couldn't see any way to make 1 work with anything and have the 3 rectangles. But I think it's because of the length of the figure.
Gotcha. So if we were going to have one of 15 long, we needed a piece that was 15. But what about the 1? Like, can't I go ahead and, oh, let me move that forward. Can't I do this and have it as a factor of 1?
And then when you do that, you can't make the other 2 rectangles.
Oh, so the shape is getting interfering there. And is there any way to move that 1 around? Can I twist it, turn it? Can I make the 1 work?
I think Andrew looked at it every possible way and he could never find a way to make 1 work. I don't see a way.
Yeah, I'm not seeing it either.
Like if you make the 1 word, it'd be more than 3 rectangles. You're learning to only get 3 rectangles.
Okay, so it's only going to work if we had the option to do multiple because we'd still have to fill in that space. Is that enough to say we're sure you can't use a 1 at all? Hmm. Laura wants to cut up and move pieces around. I also wanted to do that. Let's investigate this other idea of factors. Somebody mentioned here that 4 is not a factor, but there's a 4 in the length. Well, how can that be? What's our thinking about that? It shows up a couple times.
Teresa, maybe we need to go back and look at the prime factors with 4 being 2 squared.
Oh,
That might be it.
now that's a neat idea I didn't even think about before. So yes, maybe that 4 gets broken down. There were some other kind of interesting ones that, being a group of math teachers that I thought we could bring up. If we can take a look at slide 24. There are the last 2 on slide 24 are breaking the rules a little bit. So specifically the very last one, who did that very last one? And can you tell us a little bit about your thinking? I'm going to put a big arrow at it so we can all see which one we're talking about. Slide 24, this one with the arrow. Who did that? What were you thinking about? Maybe that person headed out or isn't using the microphone. Oh, Raha, of course I can share my screen. Thank you for reminding me. So what's happening, and maybe somebody else can answer this, what's happening here? If you understand this, if you see what's happening, go ahead, turn on your mic and tell us what is going on here.
I think we are trying to rearrange the boxes so that we can form a perfect rectangle. And we can see factors here, 5 into 6.
Absolutely. So now this is just one big happy rectangle. It's not like it doesn't have to be three little ones. Chelsea, tell us a little bit more about why you're mentioning symmetrical boxes. How did that make this easier?
Because you're able to see that the multiples are the same. So like for some of my kids, it'd be easier for them to see, oh, so I do 2 times 5 first, and then it's added 3 times. Let them see it that way. Like the same exact 30. And also like Jerry says, it's 3 sets of 10. So it's like 10 frames down there.
Oh, yeah, I can clearly see the 10 frames now. I can't unsee it now that you've said it. Very cool. What about this one over here? Now, to be completely honest, I don't know that students would come up with this one unless you had mentioned like the whole area equals 1 and what is like the fractional amount. But is the expression still equal to 30?
I might be wrong, but when I saw that, I thought of like you get the area of the whole thing and you subtract the area that you have to find the given area.
Oh, you know, Raha, when you mentioned that, it just made me think of it a little differently. Like, um, I would start out by finding the whole thing and then subtract out 2 sections. I guess that's still
Yes.
3 rectangles. That might fit the requirements. Jerry, you said you did that on slide 32. Let's go down and see. And can you explain to us your thinking? Oh, you've done 2 of them on slide 32. So Jerry, could you tell us like what you were thinking in these 2, how they're similar and how they're different? I see your mic on and not hearing you. I don't know if that's just me. If it's not working, Jerry, is there somebody in Jerry's group that was, talking with her as this was developing? Oh, no worries about it. You can definitely use the chat box. I want you to feel like you're included, even if mics are not working well. So this problem really focused on just 3 rectangles. Um, what do you notice that's different about Jerry's expressions here? I noticed they use a lot of the same numbers, but what's different about these? Feel free to write in the chat or turn on your mic.
I noticed when she did hers, a lot of us did addition, subtraction in some of theirs.
Yes, I am also seeing subtraction. And Chelsea, why do we see subtraction in this one?
Because they used a whole, but they used the yellow as a part that needed to subtract. 2 times 3, these little blocks up here.
Absolutely. And folks, one of the things that I think about as I often am wondering about tasks and bringing the rigor up is when we teach middle school, when we're in pre-algebra, a lot of times we have situations such as the distributive property or addition and subtraction of binomials, for example, and students aren't really sure how to visualize it. And so if we have these big expressions like this, and we can put an equal sign in between and say that these all represent the same amount, students are able to visualize that and they're able to make sense about many different properties. So I just mentioned the distributive property. Let's light up the chat box. What other mathematical properties do we see happening here today with these numbers? What else other than distributive? Diane, you mentioned commutative. Can you give us an example of what slide you see that on? Madhu, you said BIDMOS. Can you tell us where you're seeing this?
In the expressions and as to how we arrive at 30. Different ways of arriving at 30.
So we need to kind of remember about our grouping symbols, um, parentheses, and kind of go in that order. Awesome. And so we mentioned community property. A couple people and I were talking in groups about how does it matter which way we write 2 times 3 and 3 times 2? And I know some of you all are right in the middle of your multiplication unit here, but we can actually turn it and see it in different ways. And those are coming in the chat box right now. Slide 32, Lisa mentions 3 times 2 versus 2 times 3. Oh, I see it now too. Absolutely. All right, folks. Oh, now they're coming in. Raha saw decomposing factors in different ways. We're at the top of our hour, but I did want to point out a couple things. First of all, there were many solutions to this problem, many of them that were the same, but by selecting and sequencing just a couple key things, Christina and I got together and we're trying to figure out how do we bring up this idea that we're certain we've come up with every single one of them. I feel like this group could have had a little bit more of a conversation about prime factorization and how that can be used in an organized list to determine if we found all of them. Um, but that might be something that we're just still thinking about. In relating it up to middle school and pre-algebra, a lot of times students will start to play around with equations and introduce variables, and we start these rules. But a lot of those rules could have the pleasure of having a visual to go along with it to make sense of them. So we are thinking about that also. As just a reminder, all of these recordings are available on my website there. I also have a list of frequently asked questions on slide 39. And it has officially been seen in the wild. While I don't have a copy yet, my book is now out there. Some people have already gotten it, and you're welcome to order it. I'd love to get feedback from you all on it. And thank you so much for coming to MATHurdays. Lee, yes, there is an e version, and just about every e version you can imagine is out there. And finally, I'm going to hang out in the virtual parking lot. If any of you have any questions, I'll stay and answer them. Have a happy Halloween. I hope that you find joy in Halloween today, and a special thanks to Christina. Christina, if you want to summarize with anything else, and thank you so much for hosting today.
Thank you so much for having me. This was awesome. No, I just check out illustrative math, and Estimistries for sure. What I love about the illustrative math stuff too is just like this task. This is listed as a 3rd grade task, but you can use it at so many different levels. And I have found that with lots of their tasks, and they're really great for the kids. So thanks everybody. I had a great time, and I will still be coming anyway. I thank you, Teresa.
Absolutely. And thanks for posting the slopes and wheelchair activity here. This is really cool. Tell me again, who is the creator of this? Are you still on?
It was me, Gail.
Gail, I'd love to take a look at this. If you have any student examples on it, I'd love to see what that looks like too. If you're interested in being a guest on MATHurdays, maybe we do that one. But love the idea that you have here.
They had a nice time. Most students tend to put the inside outside in the wrong order originally because they don't understand how that slope works.
Mm-hmm.
Especially when it's written as a ratio, and even if they write it in fraction form, they still don't quite understand what's steeper and what's less steep. So it's a really good discussion, and the pictures they draw triangles, end up drawing triangles, and that really helps them.
This is such a great application to the real world. All right, folks, well, have a wonderful Halloween. I'm so glad we got to meet today, and happy MATHurdays. Dion, you want to know about ratios and proportions. Our next session is going to be on decimals, but I definitely think we could do one with ratios and proportions after that.
Okay, that's fine. I have that coming up, and I know a lot of my 6th grade teachers, because that was a 7th grade standard.
Mm-hmm.
And now, of course, it's a 6th grade one. A lot of them have a hard time with it. I had fun with it, but now I'm the math specialist, so I'm just trying to make it so they understand it as well. And I was just trying to think of something that I could, take back to them that would help them as well.
Yeah, we did one a little while ago, so I do have some recordings on here that deal with proportions, but given the grade level that you teach too, I would highly recommend proportionate Pokemon. And the idea here is you've probably heard of Pokemon before, and you can go to the index and find their real height, and then use this graph paper to actually increase the size of the Pokemon until they are proportionate to one another. So that you can really see, like, gosh, if this was a Charmander and this is a Charizard, this is how much bigger it is. And some of them grow really large, some of them not so much. And it's a great one that gets a lot of student interest too.
And that's under your template one that
Yep, it's under templates.
I go with. Okay.
But where it's also at, if you want to see it, it was from the MATHurdays on, oh, here it is, the sharing M&Ms from May 1st. The recording has both the proportionate Pokemon and this task about sharing M&Ms that deals with fractions, and that's a great one. But yeah, we need some more proportions in here. We definitely don't have enough proportional reasoning.
Okay, well, I will check them out because we're due to do proportions in about 2.5 weeks.
Cool. Yeah.
So thank you.
All righty.
I really enjoy these.
Wonderful. Glad to have you.
See you next Saturday.
All righty.
Thank you.